Okay, so we're going to do a couple of the problems that we didn't have time to go over in class. One of the problems is we're given y equals e to the tangent inverse of the square root of x squared plus 1, and we're asked to find dy. Well, we found a formula today that told us that dy equals f prime of x dx. So in order to find dy, we're going to go ahead and find the derivative of this and then multiply it by dx. So the hard part is finding the derivative of this. So to find the derivative of this, we're going to use a chain rule. So we're going to say that the derivative of this is going to equal e to the tangent inverse of the square root of x squared plus 1 times the derivative of the inside. So tangent inverse of the square root of x squared plus 1. And then we're going to multiply that by dx. Well, this here to find the derivative of that, we're going to use the chain rule again. And you can either memorize this or use the formula that we have for the derivative of an inverse. And you would find that the derivative of tangent inverse is 1 over 1 plus x squared. So in this case, the derivative of the tangent is going to be 1 over 1 plus the square root of x squared plus 1 all squared. And then we're going to have that times the derivative of the inside again, which is the derivative of the square root of x squared plus 1. And then this derivative is simply, by the chain rule again, 1/2, or the power rule this time, 1/2 times x squared plus 1 to the negative 1/2. And then using the chain rule again, we multiply this by the derivative of the inside, and we get all of that times 2x. So now, we just have to add all of that up, and multiply it all together. So we have dy equals e to the tangent inverse of the square root of x squared plus 1 times here 1 over 1 plus the square root of x squared plus 1, all of that times 1/2 x squared plus 1 to the negative 1/2 times 2x times dx. So that is our answer. Okay, so here we have another problem. It tells us that the diameter of a tree was 10 inches, and in the following year, the circumference of that tree increased by 2 inches. So the problem asks us to find how much the diameter increased and how much the cross-sectional area increased. So we know that the circumference is equal to 2 pi r. And we're told that the change in circumference is 2 inches. So we know that the change in our circumference is also given by 2 pi dr. So if 2 pi dr has to equal 2, then we can say that dr has to equal 1 over pi. So we know that our change in radius is 1 over pi. So our change in circumference on diameter is 2 over pi. So the next part of the problem asks us to find how much the cross-sectional area increased. So we know that the area equals pi r squared, and then we can find that the derivative of the area is 2 pi r dr. So we know that the radius is 5, and we know dr is 1 over pi. So we can say that the derivative of the area is equal to 2 pi times 5 times 1 over pi, which equals 10 inches squared. Don't forget your units. And this is in inches. So that's how much the area changed, and that's how much the diameter changed. As always, if you have any questions, just email me.